Okay, so in these slides, we want to do the same thing we did in the previous slides, which was to get the force on a wire, the magnetic force on a wire that has a current in it in a uniform magnetic field, but we want to just keep the integral notation. So the force is integration of I ds cross B. Now, if the magnetic field is uniform, like we did for the summation case, B is just a constant, and I is a constant. So you can take I outside and cross B outside, and the only thing that's being integrated is ds. Integration of ds is just you're cutting up the wire into small elements of length, very small elements of length, and you're adding all the vectors. You're adding this vector plus this vector plus this vector plus this vector, and so on. When you add all these vectors, you get one vector that has that starts from the first point and ends at the last point in the direction of the current, called L prime. It's exactly the same as before, but we're just doing it in integral notation. So you can replace that by L prime, and then you get a simplified formula for the force on a wire. No matter what the shape of the wire is, as long as it's in a uniform magnetic field, then it only depends on the vector L prime, which starts from the beginning point and ends at the last point.